Good afternoon, my dear student. Due to network problems, I actually face. So let us start uh, the verification of superposition theorem for a circuit having complex element that is impedance. Now you you derive the expression of I1 prime and I2 prime for the voltage source E1 or the voltage source E1. Okay, for the voltage source E1. So how do you means you write the mesh equation? How to write it? Mesh equation. So you can write mesh equation. You see there are two loops. This one and that one. So you can consider this Z1 impedance is connected in series with the parallel combination of these two impedance Z2 and Z3. So therefore the equivalent impedance for this circuit we can write the equivalent impedance. You do yourself. Impedance for this circuit, the equivalent impedance is is actually Z1 plus the parallel combination of Z2 and Z2 and Z3. Okay, everyone, see the equivalent impedance for this network is nothing but the series combination of Z1 and the parallel combination of Z2 and Z3. Okay, so therefore we can write the I1 current, that means input side I1 actually prime I1 equal to, we can write E1 divided by Z1 plus the you write what will be the Z2 into Z3. Okay, Z2 into Z3 divided by Z2 plus Z3. Okay, everyone, see that I1 current, I1 dash current is nothing but the current is the ratio of the supply voltage E1 and the equivalent impedance of Z1, Z2 and Z3. Okay, Z1, Z2 and Z3. So everyone please write the expression of I1 dash or I1 prime for this network. Now you calculate the expression for I2 dash using KVL. So I2 dash we can write I2 dash equal to how much? We can write, tell me, anyone. So I2 dash we can write, you see I2 dash actually is associated with mesh 2. So for this case we can write Z2 I2 dash Z2 I2 dash Z2 Z2 I2 dash Z2 I2 plus Z3 I2 Z3 I2 plus Z3 I prime 1 equal to how much? 0. Everyone, use the concept of mesh equation. That means you use the voltage law, KVL. The total voltage drop across a loop is nothing but the voltage drop the sum of voltage drop for individual element associated with that particular loop. So for this loop, you see there is no supply voltage. The supply, if there is a supply voltage, then this algebraic sum will be same as the supply voltage. So therefore we can write I2. You just write the expression of I2 prime. Okay, you just expression. So you know the expression of I1. You know the expression of I1. From that expression we can write I2. So I2 will be equal to minus Z3 I1 divided by Z2 plus Z3. Okay. If anyone has any doubt regarding this expression, please let me know. Now we will replace the value of I1. For the, you just mention this is equation 1, and you replace the value of I1 from equation 1 into the present equation. Suppose this is equation 2. So we can write Z3 minus Z3 into Z1 sorry E1 then E1 into Z2 plus Z3 Z2 plus Z3 divided by Z1 plus Z1 Z2 plus Z1 Z3 plus Z2 Z3. Okay, Z1 Z2 plus Z2 Z3 plus Z1 Z3. Okay, and you multiply this total terms with Z1 Z2. So this you just consider within a bracket. So we can write the remaining term Z2 plus Z3. So you see this Z2 Z3 numerator part has Z2 Z3 and also in denominator part has Z2 Z3. So these two terms will be cancel out. So we can we will get I2. We can write I2 equal to minus Z3 E1 divided by Z1 Z2 plus Z2 Z3 plus Z1 Z3. So everyone, please see the expression of I1 dash 1 and I2 dash 2. So I1 this will be I2 prime. This. Okay. So this you write this equation as equation 2. Equation 2. Okay. And you consider as a Z3 E1 Z1 Z2 Z3 Z1 Z3. Okay, so ultimate we got the expression of I1 dash prime and I2 prime for this circuit when only one supply voltage is applied to the given circuit. For this case E1. Now everyone consider case 2 when E1 is replaced by its internal impedance or internal resistance and only E2 supply voltage present in our circuit. So let me show you the circuit for case 2 when E2 is present in our circuit and E1 is replaced by a short, because we have considered here these two shorts are ideal source. Okay, so you just note down the expression of I1 and I1 dash and I2 dash. Okay, this is for I1 equation 1 and I2 or equation 2 for I2 dash. Now everyone see the circuit for case 2 when only E2 supply voltage present in our circuit and E1 is shorted out, okay, by its internal resistance. So second case. Now everyone calculate the expression of I1 prime and I2 prime for the supply voltage E2 using the concept of Kirchhoff voltage law or mesh equation. So we have already derived the expression for I1 dash and I2 dash for the supply voltage E1. In the similar manner, in the similar way, you can derive the expression of I1 dash and I2 dash for E2 supply voltage. So everyone write the expression of I1 and I2 for supply voltage E2 and you verify the result. Okay, you compare the result with okay. So first we can write I2 double dash. I2 means I2 prime I2 prime equal to I2 double prime here. So we can write this using KVL, Kirchhoff voltage law. So you see Z2 is connected in series with the parallel combination of Z1 and Z3. So therefore the equivalent resistance for this circuit, impedance, not resistance, impedance for this circuit is how much? Z1 plus the parallel combination of Z2 and sorry, I made a mistake. Z2 plus parallel combination of Z1 and Z3. Okay, this. So you can write this equal to Z2 plus Z1 Z3 divided by Z1 plus Z3. Okay, this is the equivalent impedance. So therefore we can write the expression of I2 equal to how much? E2 divided by this resistance Z2 plus Z1 Z3 divided by Z1 plus Z3. Okay, so you can simplify it. So we can write E2 into Z1 plus Z3 divided by Z2 plus Z3 plus Z1 Z3. Okay, so everyone note down this thing that I2 double prime I2 double dash equal to E2 into Z1 plus Z3 and divided by Z1 Z2 and plus Z2 Z3. Similarly, you derive the expression for I1 double dash. Okay, so this you consider equation 1. This one, equation 3. The last time we have mentioned this is equation 1 and 2. So you just consider equation 3. Now you calculate the value of I1 double dash. Okay, so everyone see the expression of I2 double dash is Z1 E2 into Z1 plus Z3 divided by Z1 Z2 plus Z2 Z3 plus Z1 Z3. So now you consider this loop, okay, this loop, and you apply KVL. You consider loop 2 and use KVL, the current associated with current I1 prime. You consider the loop, okay, with this current I2 I1 associated. Now we can write the expression for KVL or mesh equation for this loop. We can write Z1 I double dash 1 plus Z3 I1 double prime I1, then we can write plus Z3 I2, okay, equal to 0. There is no supply voltage associated with this circuit. So we can write, you know the values of I2, so you just write I1 in terms of I2. I1 equal to minus Z3 I2 divided by Z1 plus Z3. Z1 plus Z3. Z1 plus Z3. Now you replace the expression of I2 double dash in this equation. So you can write I1 double equal to how much? You just simplify. You just put the value of I2 double dash. So you will get I1 double dash equal to minus Z3 E2 divided by Z1 Z2 plus Z2 Z3 plus Z3 Z1. Okay, Z1 Z2 Z2 Z3 Z1 Z3, this thing. So ultimate you will get the expression of this I1 double dash equal to this. Now you add these two terms I1 dash and I1 double dash, which will give you the value of I1. Okay, so you can verify this thing. If you consider the mesh equation for the original circuit and you simplify, then you will get the same result. If you consider the original equation when two sources present in our circuit, and if you apply mesh equation or KVL and solve those equations, you will get the expression of I1 and I2. That expression will be same as whatever you obtain by considering individual sources E1 and E2. Okay, so therefore you can solve problems. Maybe your circuit consists of only resistances, or if your circuit consists of resistances, capacitance, inductance, then you can also solve the problem. Then you can calculate the current, voltage, whatever, okay, through superposition theorem, or you can choose KCL, KVL, whatever. But this is one approach. This is an alternative approach of KCL, KVL. You can use this approach to solve your problem. Even your circuit consists of AC source or DC source or resistances or resistances capacitance. I mean real valued element or complex valued element. So you can solve it by using the concept of superposition theorem. You just calculate the current components for individual sources, then you sum up the values of those current components whatever you have obtained for individual sources. So you will get the ultimate values of current components. So this is one approach you can use to solve your problem. Now I will give you two fundamental problems. Actually in your experiment you have used only DC source, two voltage source, DC source and resistances. Now I will give you two problems. One problem is associated with dependent source. We have considered independent sources for our experiment. So I will give you one problem associated with dependent sources, and another one the circuit consists of current source as well as voltage source. We have considered here only voltage source, and even in our experiment we have considered only voltage source, but I will give you a problem the circuit consists of voltage source as well as current source. That time how do you will solve the problem using superposition theorem. Okay, so everyone see the problem, present problem. This circuit consists of two independent sources. One is voltage source and another one is current source. So for this circuit, how do you calculate the power dissipated in the 9 ohm resistance? You see this circuit has a resistance of value 9 ohm. The question is that what is the value of the power dissipation for this resistance 9 ohm resistance. Okay, so you know the power is nothing but the product of I and V, the product of I and V. So or you can say I square R, the product of the square of current and the resistance. So you know the value of resistance 9 ohms, so you just calculate the current I current for the two sources. You see there are two sources, one is 32 volt voltage source and another one is 4 ampere current source. So everyone calculate the current for 4 ampere current source, the current value. Okay, and also the current for 32 volt voltage source. Okay, so how do you solve this problem? You first consider one source and replace another source by its internal resistance. So you know here I have you see all sources are ideal sources. Therefore you know that current source having for a current source its internal resistance is infinite. So you just open this path when you just consider 32 volt. Okay, when only one source, suppose supply voltage 32 volt source acts, okay, in your circuit, then you open this 4 ampere current source. Okay, because you know that the internal resistance of this 4 ampere current source is infinite, and you calculate the value of current for this 32 volt voltage source. After getting the value of current, you consider this 4 ampere current source and you short 32 volt voltage source, because you know that the resistance of this ideal voltage source is 0, and you calculate the current for this 4 ampere current source, and after that you add up, you just sum up these two current components, and that will be your that will be the value of current components that flows through 9 ohm resistance for these two sources. And then you use the power distribution formula P equal to I square R, and you get the result. Okay, so let me write here the power dissipated, the power dissipated in 9 ohm resistor, power dissipated in 9 ohms resistor is equal to I square R. So I, the value of current I square R. So we will calculate the I square for this circuit, and R we know, R equal to 9 ohm. So now we will first consider the voltage source 32 volt, and we will short out this 4 ampere current source. So you just calculate. Everyone tell me the value of the current for 32 volt voltage source. 32 volt voltage source. Everyone solve it yourself. Okay. So if I consider this is sorted, that means you see this resistance means 6 plus 9, 15 ohm resistance and 12 ohm resistance are in parallel combination. Okay, and this parallel combination is connected in series with 4 ohm resistance. So for the circuit, you just write when voltage source 32 volt, voltage source 32 volt, voltage source of 32 volt acts alone. Okay, that case we can write the equivalent resistance. Everyone solve yourself and let me know the answer. Equivalent resistance is equal to how much? 4 ohms plus the parallel combination of 12 ohms and the sum of this two series resistance 6 plus 9. Everyone see the equivalent resistance will be this 4 plus 12 parallel combination of 12 ohm resistance and 15 ohm resistance. So you know 4 plus the product of this 12 into 15 divided by 12 plus 15. Okay, so ultimate you will get the expression of equivalent resistance for this case how much? 32 by 3. 32 by 3. You just simplify this thing. You will get 32 by 3 ohms. Okay. (32 by 3 ohms). The expression, you just use a symbol. Then you calculate the value of current. Okay, the value of current. So we can write the value of current is how much? The value of current is how much? 32 volt. If you short this one, so for this 32 volt source, use the current flow through 4 ohm resistance. You write the current T through the 4 ohm. The current through 4 ohm resistance is equal to how much? 32 divided by 32 by 3. That means 3 ampere. 32 by 3. So you can write 3 ampere. Okay. If you have any doubt, please let me know. Everyone see. First we have considered only one source, that is voltage source, 32 volt voltage source, and we sort out the 4 ampere current source. Not sort out, sorry, we actually open the 4 ampere current source because this internal resistance is infinite. We have considered ideal source, and after that we we can see that 4 ohm resistance is connected in series with parallel combination of two resistance 12 ohm and 15 ohm. And finally we calculate the equivalent resistance for the circuit, and after that the current values, the current flow through 4 ohm resistance is equal to 32 divided by the equivalent resistance, that will be equal to 3 ampere. So after getting the 3 ampere voltage, you see this 3 ampere 3 ampere current. After getting the 3 ampere current, you see this 3 ampere current actually divided into two parts. One part actually flow through 12 ohm resistance and another part through 15 ohm, this series 6 and 9. Okay, so then we can write the current flows through 9 ohm resistance. The current the 9 ohm resistance 9 ohm resistance equal to how much? You use current division rule. This 3 ampere current is divided into two parts. Okay, so we can calculate the current for individual component using current division rule. So therefore 3 ampere into opposite resistance 12 divided by the sum of two resistance 12 plus 15, 12 plus 15. Okay, everyone try to understand. If you have any doubt, let me know. Here you see that 9 ohm resistance, we have considered that our objective is to calculate the current for 9 ohm resistance, but here we have written 15 ohm because you see that the current flow through 15 ohm resistance is nothing but the current flow through 6 ohm and 9 ohm resistance. That means the current which flow through 9 ohm resistance is same as the current flow through the 15 ohm resistance. So therefore we can write this current values is 4 by 3 ampere. Okay, 4 by 3 ampere. Now you calculate the current value for another source, that is current source. For current source, okay, we have calculated the value of current which flows through 9 ohm resistance for 32 volt supply. Now you calculate the current value for another source, 4 ampere current source. When you will consider only current source, then you short out the voltage source. So therefore for second case we can write you consider only current source acts alone. Okay, when current source of 4 ampere acts alone in your circuit, then you can write that you consider this voltage source is shorted. So that case you write the value of current. You see the 4 ampere current is divided into two part. One part will flow through 9 ohm resistance and another part will flow through equivalent resistance, I mean 6 ohm resistance, equivalent resistance of 6 ohm resistance and parallel combination of 12 and 4 ohm resistance, so therefore we can write the value of current components. The value of current component for this case is equal to, using current division rule, we can write, if anyone have any doubt, please let me know. Current division rule, we can write the current So the 9 ohm resistance for 4 ampere current source, 9 ohm resistance, okay, due to 4 ampere 4 ampere current source is equal to 4 into opposite side resistance. Okay, so everyone tell me the value of equivalent resistance. 6 ohm and parallel combination of 12 and 4. Okay, 12 and 4, you tell me the value of current. So you can write the 4 into 6 plus the parallel combination of 12 and 4, this resistance divided by sum of the two resistance. So you can write 9 plus 6 plus 12 parallel combination of 4. Now everyone write the values of current which flows through 9 ohm resistance when only current source present in your circuit. Okay, current source present in your circuit. So you know the current division rule. So you see the total current is 4 ampere. This current is divided into two branches. I mean flow through two branches. One is 9 ohm and another one is the equivalent resistance for 6 ohm and parallel combination of 12 and 4 ohm resistance. So ultimate you will get this value. Okay, so this one equal to, you can write, you will get, you just simplify this thing, you will get the value of current component I2 double prime equal to 2 ampere. Okay, 2 ampere you will get. Everyone verify this thing. So therefore the total current which actually flows through a 9 ohm resistance, 9 ohm resistance for two sources equal to 4 by 3 plus 2. This amount of current you will get equal to, you will get how much? 10 by 6, 4 plus 6 divided by 3. So equal to, you will get 10 by 3 ampere. Everyone verify it yourself, 10 by 3 ampere. Okay, so now we can calculate the power which actually dissipate through this 9 ohm resistance. Okay, by taking the product of this current component I 10 by 3 whole square and 9 ohm resistance. So therefore the dissipated power, the power dissipated dissipated in 9 ohm resistance is equal to 10 110 by 3 this term square into how much? Into 9. Therefore you will get 100 watt 100 watt power dissipated. 100 watt. Okay, 100 watt power dissipate will dissipate through 9 ohm resistance when two sources present in your circuit, 32 volt voltage source and 4 ampere current source. So by using superposition theorem we can calculate the value of dissipated power in 9 ohm resistance. There are alternative approach available. You can use that approaches to solve this problem, but here actually we have used the concept of superposition theorem. Okay, anyone has any doubt regarding the solution of this problem? Please let me know, or you write your confusion in chat box. If anyone face any difficulty to solve this problem, Orkodeep goes no. Thank you, Orkodeep. Okay, so this is an application. This is an example of application of superposition theorem to solve circuit theory problem. But I am telling you that in any exam you can use any theorem, any laws. Which one is perfect to solve your problem? I mean, which one actually will take less time to solve the given problem? You use or you consider that theorem or that laws. Okay? No, there is no actually hardened rule that you will use superposition theorem or you will use Kirchhoff voltage law, current law. I will discuss later on Thevenin's Norton. You can use any theorems and any laws to solve your problem, but you first try to understand who is one actually among these available laws and theorem, who is one will help you to solve the particular problem in less time. You will use that one. Okay, now okay, this is one problem. The problem consists of two sources, current source and voltage source. And the previous actually in your lab class you have solved the problems using superposition theorem basically for only voltage sources. So therefore you can solve this problem using superposition theorem by superposition theorem when your circuit consists of current source or only voltage source or both. Now I will show you another problem where the circuit consists of dependent as well as independent sources. Okay, dependent and independent sources. Okay, everyone. So therefore you can solve circuit theory problem using superposition theorem for a circuit consists of either only voltage source or current source or even both voltage source and current source. But so far we have we have actually discussed the application of superposition theorem only for independent sources. But in this case we will use superposition theorem to solve circuit theory problem having dependent as well as independent sources. Okay, you see the present circuit consists of four sources. Among these, two are voltage sources and one is current sources, and the remaining one is dependent voltage sources. Okay, the circuit has total 4 number of sources. Among these 4, 2 are independent voltage source, 1 is dependent voltage source, and the remaining one is a current source, 5 ampere current source. Now the question is that determine the voltage V in the network shown below. Determine the voltage V in the network shown below. Everyone calculate the value of V using superposition theorem, or you can use KVL, KCL, whatever. I have no problem. You just tell me the answer of this problem. What will be the value of V? You see, and one thing you remember, I hope you already solved Thevenin's problem in your second semester course for dependent as well as independent sources. If you have that concept, you can use. Otherwise, let me tell you, for voltage source, you replace the voltage source by their internal resistance, I mean 0, short it, and for current source you open it. But for dependent sources, don't replace the dependent source by short or open path. Okay, you always consider dependent source when you will calculate the current or voltage for individual sources, independent sources, I mean. Okay, here in this circuit you see there are 3 independent sources. When you want to solve the problems, when you want to calculate the value of V or current, whatever, for the individual independent sources, you must consider the dependent source in your circuit. You must consider dependent source. Don't replace dependent source, okay, by short or open path. Okay, so anyone can help me to solve this problem? How do you solve this problem? Anyone can tell me this problem, to solve this problem? Okay, so let me write the equation. First, we will consider only one source. Suppose we will consider when voltage source 30 volt acts alone. In this case, you replace this 5 ampere source by an open path and this 20 volt by a short. Okay, so ultimately you will get like this a circuit. Okay, circuit having 30 volt voltage source, 6 ohm resistance, 2 ohm resistance, 3 ohm resistance, and a dependent source having dependent source voltage V by 3. Okay, so for this case you calculate when voltage source 30 volt acts alone, that time you calculate the value of V1. Okay, 30 volt. So what will be the value of V for 30 volt sources? Okay, so you use KCL for this node, KCL for this node. So you see the value of this node, voltage drop for this node is V. So by KCL we can write, by using KCL we can write 30 volt minus V divided by 6 ohm. Okay, divided by 6 ohm. Everyone try to understand this one. Equal to how? This current is divided into 2 parts. Okay, not this current. This current actually this current enters to this terminal, and you will get another current. You will write my plus for this dependent source. How much you will get for the dependent source? 30 you consider V 30 you write V by 3 minus V divided by 2. Everyone try to understand. Divided by 2 equal to how much? Equal to V by 3. The current, first you consider 30 volt voltage source, and you write the expression of current by applying KCL. So you see the current enters into this terminal point. For this 30 volt source is 30 minus V by 6, and for this dependent source is V by 3 minus V divided by 2. This actually, the sum of current actually propagated through this 3 ohm resistance. The entering current is equal to the sum of these two current components, and leaving current is equal to V by 3. So by solving this equation, you can write V equal to small v equal to 6 volt. V equal to 6 volt. Okay, but you just change this expression V intra V1, because we will calculate the value of V for 5 ampere and also for 20 volt. So ultimately you will take the sum of all V. So you just change this V1, otherwise you will get you will confuse regarding this. Okay, so then you consider when current source, you calculate 20 volt also, voltage source 20 volt, epsilon. That case you will suppose you consider V2. So V2 equal to how much? V2 will be equal to, first you write the KCL, means equation of node equation for 20 volt source, node equation. Okay, 20 volt you write the node equation. For 20 volt you don't consider, you just consider this loop. You use loop equation, it will help you to solve this problem easily. You consider a loop equation, so you using KVL for this loop. You just short this one, open this one and short this one 30 volt and open 5 ampere. So your circuit will consist of 20 volt, 2 ohm resistance, V by 3 dependent source voltage, 3 ohm resistance and 6 ohm resistance. Now you consider this loop. For this loop you can write KVL. So you can write, and you consider minus 2I, current propagate 2I minus 20 volt minus 2I minus V by 3 VI by 3 equal to how much? Equal to 0. You see for this loop 20 volt 2I Vi by 3, Vi by 3, and the parallel combination of 2, 3 and 6 ohm resistance. So how much? 3 into 6 divided by 9 and 9. Okay, minus 2i, this one, and this v 1 by 3 minus 2i. Everyone check the expression. There is a mistake. You write this is minus 2i, minus 20, minus 2i. This will be also minus 2i, minus 2i. And you solve it. Okay. So current value you will get from this equation, or I equal to, you can write I equal to 6 ampere. 6 ampere. So if you know the value of I, then you can calculate the V3 value. Suppose this one you consider, this is not V, you write 2i by 3, because this V equal to 2i, so you can write 2i by 3. One thing, the equivalent resistance, since you write in the bracket, since equivalent resistance, or you write parallel combination of 6 ohm, equivalent resistance of parallel combination of 6 and 3 equal to how much? 6 into 3, 18 by 9, but 2. The 18 by 9 equal to 2. Okay. Equal to 2. This is the equivalent 2 ampere. So 2, you have considered the current flow through this circuit is I in clockwise direction. Here we have considered, you write in the bracket, I current flows through this circuit, in clockwise direction. You write along the clockwise direction. Along the clockwise direction. Okay. So then you can write this expression, and you see this equivalent to 2 and I current. Therefore we can write, if you consider V3, so you can write, therefore the voltage drop across 3 ohm resistance, 3 ohms resistance equal to 3 ohm resistance. Suppose V3 equal to 3 equal to how much? 2i, because the equivalent resistance of this 2 is 2, and this voltage drop will be same V, the V3 equal to 2i. Okay, so this voltage 2i by 3. Therefore we have written 2i for this case. Voltage drop across 2 ohm resistance is 2i, 20 volt supply voltage. Voltage drop for this parallel combination of 3 ohm 6 ohm resistance is 2, and for this case 2i. Okay, and V equal to 2i. So therefore the voltage drop for this dependent source is 2I by 3. So therefore I equal to 6 ampere. So we can write V3 equal to how much? 6 into 2, 12 ampere. So V3 equal to, you can write V3 equal to you can write V3 equal to, you can write how much? V3 equal to 12 volt. 2 into 2 into 6 equal to 12 volt. Any doubt? 12 volt. Okay, everyone try to understand the solution of this problem. First you consider the supply voltage 30 volt, then you consider 20 volt, and finally you consider 5 ampere current source, and for that case you will get V2 equal to minus 6 volt, and you solve it yourself. For when only current source, when current source, how much value of current source? 5 ampere. 5 ampere acts alone. Then we can write using KVL, not using KCL. For this case, using KCL, we can write V2. Suppose you consider V2 minus minus how much? V2 by 6 minus 5 ampere minus V2 by 3 plus how much? Write yourself. V2 by 3 minus V2 divided by 2 equal to 0, or we can write V2 equal to minus 6 volt. So therefore the voltage V for this four sources is nothing but the sum of V1, V2, V3. So therefore ultimately you will get the result. So finally we can write therefore V equal to V1 plus V2 plus V3. So equal to how much? 6 minus 6 plus 12. So equal to 12 volt. Okay, any doubt, any confusion? So therefore we can solve problems, circuit theory problems associated with dependent source as well as independent source, current source, voltage source, whatever, by using superposition theorem. But for this case we need to consider dependent sources one by one, but independent sources one by one, but dependent sources will be always present in our circuit with independent sources. Okay, this one thing everyone remember, that keep in your mind, that for to solve circuit theory problem for dependent sources, you need to consider them for each and every cases when you consider independent sources individually. Okay, when you consider individual sources, independent sources individually, that time you must consider dependent sources along with independent sources. Okay, so this is only this is the difference. Otherwise the same approach whatever you have applied for independent sources, maybe current source or voltage source, only one difference for dependent source is that we need to consider it throughout the process. Okay, we cannot replace dependent source by their internal resistances. Okay, on the other hand we can replace independent sources by their internal resistances. Everyone keep in your mind that to solve circuit theory problem either using superposition or Thevenin's, whatever I will discuss later on, dependent sources always will be present in our circuit, dependent sources, but we can replace independent sources by their internal resistances. Any doubt? If anyone has any doubt to solve this problem or difficulty, please write in the chat box. And one thing you remember that superposition theorem is applicable only for linear bilateral passive element. Linear bilateral passive element. Okay, so don't use this theorem to solve problem associated with active component or unilateral element, transistor, diodes, etc. Okay. If anyone has any doubt to solve this problem, please write your confusion in the chat box. Okay. In next class, we will discuss about Thevenin's theorem, Norton's theorem, and then reciprocity and compensation. Okay. So you read yourself about these theorems and try to solve problems, circuit theory problem using the concept of this theorem. If you face any problem or difficulties, please let me know. Thank you everyone. Okay.